Hello class, and welcome back to section 8.3, graphing rational functions. I hope you grabbed your graphing calculator because we're going to go ahead and graph some rational functions. So for questions 4 through 7, graph the function shown, list the location of any vertical asymptotes or holes in the graph, and so we want to make sure we graph those as well. Biggest thing that we're going to do is if we're graphing this, I would recommend finding your holes and your vertical asymptotes first. Okay, so if I look at this function, does anything cancel here? No, nothing cancels. So in this case, there is no holes. Okay, so there's no holes. The next thing I would do is figure out my vertical asymptote, which comes from my denominator. So my vertical asymptote comes from x minus 2. Remember setting that equal to 0. So x is equal to 2. I'm going to graph that on there. We always graph it as a dashed line, and it's vertical, so straight up and down. So at x equals 2, it's a dashed line. Okay, there's my vertical asymptote, and I'm going to label it at x equals 2. Then in order to graph it, you typically take your vertical asymptote and you put it in your table. Okay, so here's where 2 would be. If you plug in 2 on your calculator, it's going to tell you that there's an error. So we do not include it in our table. Okay, so if you look here, this was where our 2 is, so we don't include it. Then the way you pick your values for your table is always do 3 or 4 values bigger than 2. So bigger than 2, 3, 4, 5, 6. And 3 to 4 values less than 2. 1, 0, -1, -2. Okay? Then, if you do not have a graphing calculator, you're just going to have to take each one of these values and plug it into your calculator. So for instance, if I have f of -2, I would have -2 over -2 minus 2. So this is -2 over -4, which gives me positive 1/2. And you'd have to do the same thing for all of these values. If you have a graphing calculator, we're going to walk through the steps on how to graph this function on your calculator. So on our graphing calculator, what we will need to do is you go to the y equals, and I would recommend maybe writing the steps down. We go to y equals, and we enter in the equation. The biggest thing is to put your denominator in parentheses. So it'd be x divided by parentheses x minus 2. Okay? And if you just go ahead and hit the graph button, it will show me my rational function. And just to remind you, rational functions are not continuous. Typically, you see I'm drawing here, then I would have to pick up my pencil to continue drawing over here. So this is not continuous. And if you look, it's at x equals 2, where my vertical asymptote is. Okay, so graphically, this is typically what rational functions look like. They have that asymptote, and they're kind of flipped, if you notice, flipped across, So there is an example. Now let's go ahead and so we can figure out what to fill in my table of values. So I'm going to go to my table set, which is above window, so second table set. In my table, it starts at -2, so my table start, I'm going to type in -2, enter, and remember your delta table is just saying what you're going to count by. So this one's counting by 1, so that means I'm going to do -2, -1, 0, 1, 2, and continue. Okay, then I would actually go ahead and look at my table. So my table, I would go, it's above graph, so second table. And if you look, -2 gives me 0.5. If I plug in -1, I get 0.3 repeating. Plug in 0, I get 0. Plug in 1, I get out -1. And look at what it says for 2. This is a good indicator my vertical asymptote is here, or a hole. If I plug in 2, I get an error. Okay, so that's why we don't include that one in our table. So I'm going to go ahead and copy this information onto my table on my sheet over here. Okay. So it was 0.5, then it was 0.3 repeating. Then I get 0, -1, 3, 2, 1.6 repeating, and 1.5. So I'm going to go ahead and plot these values. So at -2, I have 0.5. At -1, I have 0.3. At 0, I have 0. At 1, I have -1. And then notice at 3, I have 3. So this is where it kind of jumped across. And then at 4, I have 2. 5, I have 1.6. At 6, I have 1.5. So I'm going to go ahead and graph this. notice, looks just like the graph on my calculator. So you guys can always go ahead and check your answers if you have that graphing calculator. That's why it's so handy, to make sure it looks like what it should look like on there. So there is example 4. And once again, if I pull up my calculator and I go to if I just hit the graph screen, I would notice, do they look the same? Yes, they do. So I did number 4 correctly. Okay, let's go ahead and look at number 7. Sorry, not number 7, number 5. Same idea. Let's start out figuring out if there's any holes, and then we'll figure out if there's any vertical asymptotes. So remember, holes is if it cancels. Nothing cancels here. Okay, so I would have no holes. Then I go ahead and figure out my vertical asymptotes. Comes from setting my denominator equal to 0, so x equals -1. Notice, once again, -1 would be right here on my table. I'm not going to give you a table. You'll have to be making your own tables on your homework. So notice, I base my table off of my asymptote. So it's at -1, so I pick 4 numbers less than -1 and 4 numbers bigger than -1. So there they are listed. I'm going to go ahead and draw my vertical asymptote on the graph. X equals -1. There it is. I'm going to label. Okay. Now I'm going to go ahead to my calculator, and if you don't have a graphing calculator, like I said, you're going to have to just plug each one in. So going to my graphing calculator, just to repeat, my first step, go to that y equals. In this case, I'm going to clear it out, and I'm going to type in x divided by, now make sure you put your denominator in parentheses, x plus 1. Okay. And now I'm going to go ahead and look at the graph of it so I kind of get an idea of what it looks like. So I hit graph. Remember, my vertical asymptote was at -1, and it looks like this one is graphed that way, so that's good. Now I'm going to get my table values. So I go to table set, which is above window, so second table set. And my graph doesn't start at -2 this time, it starts at -5. So I do -5, and I still want it to count by ones. Okay, so then I go to second table, which is above graph, to actually get my values. Once again, point out my vertical asymptote's at -1, and on my calculator, I get an error. So I'm going to go ahead and copy this stuff down onto my note sheet here, and you should do the same. Make sure you're doing this on your calculator as you go along, because you want to be able to make sure you can do this as well. So 1.25, 1.3 repeating. And then after I go ahead and fill in my table, I'm going to go ahead and graph these. So I have -5, 1.25, -4, 1.3, so it's getting a little bigger every time. -2, 2. Oh, I'm graphing these as negative, aren't I? These are positive values, so I need to fix that. At 1, it's 0.5. At 2, it's 0.6. At 3, it's 0.75. Okay, so my graph, if I connect them, remember it gets really close to that asymptote. We do not actually draw over it. Okay, so make sure you don't cross your vertical asymptote when you draw it. And here, there would be my graph of example 5. And once again, I would check with the graph on my graphing calculator. So I would go hit graph, and I would ask myself, does the graph here look similar to the graph here? Yes, it does. That's the nice thing about your graphing calculator. You can make sure that you're doing it exactly correct. All right. Then let's go ahead and look at example 6. First things first, I need to see if there's any holes. In this case, I need to factor this problem first. So I would have f of x is equal to x plus 3, x minus 3, all over x plus 3. Remember, the holes are for what cancels out. The x plus 3's cancel. So my hole is when I take x plus 3 and set it equal to 0. So there's a hole at x equals -3. Remember, how I figure out what my value is by ignoring what was canceled out. Okay, so if I plug in my -3 now, it's going to be -3 minus 3, which gives me -6. So my hole is at the ordered pair -3, -6. So on my graph, I'm going to graph that and I do an open circle. Okay. Now in this situation, I look, is there a vertical asymptote? There's nothing left here. So in this case, there is no vertical asymptote. All right, so now I need to go ahead and I need to graph the rest of this. Well, I would recommend making your table based around your hole, since there is not a vertical asymptote. So at -3, so just think -3. So let's think of numbers less than -3. -4, -5, -6, and then numbers greater than -3, -2, -1, 0. Okay, and what you do is you're going to go ahead and plug those into what is left here. Okay, so if I plug in 0, 0 minus 3 would be -3, and once again you could use your graphing calculator. This one's pretty easy though. -1 minus 3 is -4, -2 minus 3 is -5, -4 minus 3 is -7. -5 minus 3 is -8, and this gives me -9. And I'm going to plot these points to see what happens. So I have 0, -3, -1, -4, -2, -5. That's my hole. And then I have -4, -7. And these ones don't fit on my graph. But if you look, this one's just going to go ahead and form a line. Okay. And then once again, I want to check to make sure I did this correctly. So I'm going to graph it on my graphing calculator. So I go to my y equals, clear it out. And now this one, since there's a binomial in my numerator, I need to put in parentheses. So I would have x squared minus 9 divided by, and then parentheses, x plus 3. Okay, and let's go ahead and see graphically what that looks like. Does it look like a nice line like I have on mine? Yes, it does. One way to check to make sure there's a hole, you can always go second calc. Okay, and my hole, okay, I want to figure out the value, so value, sorry. And my hole is where my x value, well, we want to figure out where when x is equal to, and I'm going to type -3. And if you look, it will not tell me a y value, so there is a hole there. It's harder to see on a graphing calculator. They don't really show an open circle, so something to be aware of. All right, so there is example 6. Let's go ahead and move on to our last example, example 7. So same thing here. We need to figure out if there's a hole in our vertical asymptotes. So I need to factor my numerator. It's a difference of perfect squares, so it's x minus 2, x plus 2, all over x minus 2. And if you see, your x minus 2's will cancel, so that means that there's a hole when I take those and set them equal to 0. So there's a hole at x equals 2. Now remember to figure out where your hole is. You're just going to go ahead and it's whatever is left after you canceled. So my f of x function that I will be using is x plus 2. And I plug in this value. So I find f of 2. So it's 2 plus 2, which is equal to 4. So my hole is at 2, 4. So on my graph, I go ahead and I plot the point 2 and I graph it as an open circle, 2, 4. Okay. Now I look, do I have any vertical asymptotes? Well, there was nothing left in the denominator that didn't cancel, so in this case there is no vertical asymptote. No vertical asymptote. And now I make my table. Once again, I would base it around my hole. My hole is at 2, so that one will provide an error. So let's pick some numbers less than 2, 1, 0, -1, and some numbers bigger, 3, 4, 5. If I plug in 1 to what is left, 1 plus 2 is 3, 0 plus 2 is 2, -1 plus 2 is 1, 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7. Okay, so let's plot these. At -1, I have 1. At 0, I have 2. At 1, I have 3. At 3, I have 5. At 4, I have 6. So once again, it's looking like I have a line with my open circle, though. Make sure you don't draw anything through it. And then let's go ahead and check to make sure I graphed it correctly. So once again, I go to my y equals, clear it out, and I put my numerator in parentheses, so it's going to be x squared minus 4 divided by x minus 2. And I go ahead and hit graph. And if you look at this one, I'm going to move it off to the side. Does it look similar? Yes, it's crossing at the same point. The other thing I could do is go ahead and just check out my table. So remember, I go second table set, and my table here starts at -1. So I'm going to start at -1. It's going up by 1, so I'm going to go second table to go ahead and look at that. If I look at my table, I have 1, 2, 3, so I 1, 2, 3 here. Then I have my error, then I have 5, 6, 7. So my table is graphed correctly as well. So there is how to graph rational functions. Always make sure you find your whole and your vertical asymptote first. Also, your calculator is a great tool for you to be able to use. So if you have any questions about that, please come and ask me. Otherwise, have a great day, and I will see you later.